So in this problem, we need to determine the coordinates of the incenter of a triangle. It's given here that the midpoints of the side of the triangles have coordinates 1, 1, 2, -3 and 3, 4. Let us begin. So we will begin by considering a triangle having the vertices A, B and C. We'll also consider the midpoints of the sides. So let's say D is the midpoint of side BC, E is the midpoint of side AC, and F is the midpoint of side AB. We will suppose that D has the coordinates 1, 1. E has the coordinates 2, -3, and F has the coordinates 3, 4. Also, we will specify the coordinates of A. So we'll suppose that the coordinates of A, let it be denoted by x1, y1. That's not given to us though. We need x2, y2, which will be the coordinates of B, and we have the coordinates of C given by x3, y3. The reason why we are choosing the coordinates of A, B and C because we need to find out the coordinates of the incenter of a triangle. And we know that if we want to find out the coordinates of the incenter, we also need information regarding the coordinates of the vertices. Okay, so given from the coordinates of the midpoints, we will have to find out the coordinates of the vertices. So let's do that. Now we'll start with the midpoint D. Now since D is the midpoint of BC, so let's write it down. Since D is the midpoint of side BC, so here we can say that if we add up the x coordinates of the endpoints, so that means the endpoints will be B and C. So if we take the sum of the endpoints, which is x2 plus x3, and divided by 2, and for the y coordinate, we take the sum of the y coordinates, y2 plus y3, and divided by 2. So this is going to be the coordinate of the midpoint D. And this is given that this value is 1, 1. Now since these two coordinate points are equal, then immediately we can say that x2 plus x3 over 2, this must be equals to 1. And then we have y2 plus y3 over 2, so that will be equals to 1. Fine. So we will cross multiply. That gives us x2 plus x3 equals to 2 times 1. So that will be 2. We're going to label this as equation number 1. Then we have y2 plus y3. This will be equals to 2. So that gives us the other equation, equation number 2. The next what we'll do, we'll consider E. So E is the midpoint of AC. Since E is the midpoint of AC, then we can define the coordinate of E. That will be simply, we'll take the sum of the x coordinate of the endpoints, which is x1 plus x3, divided by 2. So this is going to correspond to the x coordinate of the midpoint E. And to find out the y coordinate of the midpoint E, what we'll do, we'll take the sum of the y coordinates of the endpoint. So that's y1 plus y3 divided by 2. So this is the coordinate of point E, and it's already given here that this value corresponds to 2, -3. So when we equate them, we are going to get the equation x plus x1 plus x3 over 2, that will be equals to 2, and then we have y1 plus y3 divided by 2, so that will be equals to -3. So this gives us two equations, x1 plus x3 equals to 4, and we have y1 plus y3, so that will be equals to -6. Fine. We're going to label this as equation number 3 and equation number 4. Then finally, we're going to consider the midpoint F, and using the simpler method, so we can get two more equations. So let's find it out as well. So the coordinates of the midpoint of F, that will be simply sum of the x coordinates of the endpoint, which is x1 plus x2 divided by 2, and the y coordinate will be sum of the y coordinates of the endpoint, y1 plus y2 divided by 2, and this will be equals to the midpoint value which is given to us, so it's 3, 4. Okay, we'll substitute here 3, 4. Solve this to get two set equation, that is x1 plus x2. This will be equals to 6, which will be equation number 5. And then we have y1 plus y2, so that will be equals to 8. So that's going to give us another equation, 5 and 6. Now what we'll do, we'll take equation 1, 2, 3, 4 and 5, 6 and use them to obtain the value of x1, x2, x3 as well as y1, y2 and y3. So let's do that. To begin with, what we'll do, we'll use equation 1, 3 and 5 to obtain the value of x1, x2 and x3. So let's do one thing. Let's take equation number 1, and from it we're going to subtract equation number 3. So that's going to give us, so we have x3 cancelling out. That leaves us with x2 minus x1. So this will be equals to 2 minus 4. So that's -2. So we get a new set of equation containing x2 and x1. Now what we'll do, we'll take equation number 5 and we're not going to do anything to it. So we'll rewrite it as x2 plus x1 equals to 6. What we'll do, we are going to take the sum of the two new equations. So we have x2 added to x2, that gives us 2 times x2. So negative x1 and positive x1 cancels out. This will be equals to negative 2 plus 6, so that's 4. Now we will divide both sides with 2, so that will give us the value of x2. So x2 comes out to be 2. Now let's use equation number 1. So in equation number 1, we'll substitute the value of x2 with 2. So we have 2 plus 3, 2 plus x3. So that's equals to 2, which means the value of x3 is simply 0. Then we will substitute until let's take equation number 2. Now in equation number 2, we need to find out the value of x1. x1 added to x3. So x3 we obtained its value as 0. So x1 plus 0 equals to 4. So this tells us that the value of x1 must be equals to 4. Okay, now we have found out the value of x1, x2 and x3. We'll try to find out the value of y1, y2 and y3. So let's take equation number 2 and from it we're going to subtract equation number 4. So that is going to give us y2 minus y1 equals to, so 2 minus of minus 6 is going to be 8. We'll keep a 6 as it is. So 6 is y2 plus y1 equals to 8. We'll add the two equations. So that gives us 2 times y2 equals to 16. So y2 comes out to be equals to 8. Now that we have the value of y2, we can use it to obtain the value of y1 and y3. So let's use equation number 1, or equation number 2. So here we have the value of y2. So 8 added to y3. So that must be equals to 2. So this gives us y3 equals to 2 minus 8. So that's negative 6. Fine. And then we'll try to find out the value of 4. So 4 is y1 plus y3. So what's y1 here? Y1 we need to obtain. And this is added to y3. y3 is negative 6 equals to negative 6. So that means solving for y1, we get the value equals to 0. So now we have the values of x1. So let's say x1 comes out to be 4 and y1 gives the value 0. So this is going to be the coordinate of vertex A. So that's 4, 0. Then we have x2. So x2 came out to be 2 and y2 has the value equals to 8. And that means the coordinate of vertex B, so that's going to be 2, 8. And then we have the value for x3. So x3 came out to be 0 and y3 has the value equals to negative 6. So that means coordinate of C is going to be 0, negative 6. So now we have obtained the coordinates of the vertices. So let's go back to a triangle. So we have the coordinates of the vertices of the triangle, and in order to find out the coordinate of the incenter, we'll also need the information regarding the sides of the triangle. So we'll start with side AB. Now clearly AB is opposite to angle C, so we're going to consider it to be C. So AB is C, and we can find out the length of AB by using the distance formula. So we'll take the square root, and then the square root, what we do is take the difference of the x coordinate. So that's 4 minus 2, square it and add it to the difference of the y coordinate. So that's 0 minus 8 squared. So this has the value. So we have square root of, so 4 minus 2, that's 2. 2 squared will be 4. Plus 0 minus 8, that's simply negative 8. Square of 8 is going to be 64. So that means we have square root of 68. Then we come to BC. So BC is the side that's opposite to angle A. So we're going to denote it by the letter A. So we have A. So this has the length given by, we'll take the difference of the x coordinate. So that's 2 minus 0, square it and then add it to the difference of the y coordinate. So we have 8 minus negative 6. So we get 8 plus 6 whole square. Now this will be equals to square root of 4 plus, so 6 plus 8, that's going to be 14. So 14 square is 196. So that corresponds to value square root of 200. The square root of 200 will be simply 10 times square root of 2. We can also simplify square root of 68. So that is going to be 2 times square root of 17. And then finally, let's find out the value of CA. Now CA is the side opposite to angle B. So we're going to denote it by the letter P. So P is given by, we have the square root. Underneath the square root, we take the difference of the x coordinate. So that's 4 minus 0 squared and add it to the difference of the y coordinate. So that's going to be positive 6 squared. So we have a 4 squared, that's going to be 16, and 6 squared, that's 36. So this gives us a value equals to 52, and square root of 52, that's 2 times square root of 13. Now we have the length. So let's note it down. So A came out to be equals to 10 times square root of 2. B has the value equals to 2 times square root of 13, and C has the value 2 times square root of 17. Now we have the triangle ABC. We know the coordinates of its endpoints and we also know the length of its sides. Now what we can do, we can find out the coordinate of the incenter, which is going to lie somewhere here. Let's say the coordinates of the incenter I, that's given by AX1 plus BX2 plus CX3 whole divided by A plus B plus C. So that's the X coordinate. And the Y coordinate will be AY1 plus BY2 plus CY3 whole divided by A plus B plus C. Or now what we'll do, we'll substitute the respective value. So we have A, so A comes out to be 10 times square root of 2. So this is going to be multiplied with x1. So here x1 corresponds to the X coordinate of A, so that's 4. So we multiplied to 4 plus B, so B is 2 times square root of 13. Multiplied to x2, x2 is the X coordinate of B, so that's simply 2. Added to CX3, so what's C? So C has the value 2 times square root of 17 multiplied to x3, x3 is the X coordinate of C, so that's simply 0. Whole divided by, we'll have to take the sum of A plus B plus C. So we have 2 times square root of 17 plus 10 times square root of 2 plus 2 times square root of 13. And coming to the Y coordinate, so we have A, so A is 10 times square root of 2. This will be multiplied to Y1, so Y1 corresponds to the Y coordinate of A, so that's 0. Plus B, so B here is 2 times square root of 13. This will be multiplied to Y2, so Y2 corresponds to the Y coordinate of B, so that's 8. Plus C, so C here is 2 times square root of 17, and that will be multiplied to Y3, so Y3 is the Y coordinate of C, so that's negative 6. Whole divided by A plus B plus C. So we have 2 times square root of 17 plus 10 times square root of 2 plus 2 times square root of 13. So let's simplify this. So we now have I, this is the coordinate of the incenter. So we have 4 times 10, so that's 40. We have 40 times square root of 2 added to. So we have 2 times 2, so that's 4. So 4 times square root of 13. And this is simply 0. Divided by, we have 2 times square root of 17 plus 10 times square root of 2. Then we have 10 times square root of 2 times 0, so that's 0. So we're 2 times 8, so that's going to be 16 times square root of 13. And then we have, this is going to be negative 12. So we have negative 12 times square root of 17. And the denominator, we have 2 times square root of 17 plus 10 times square root of 2 plus 2 times square root of 13. Now what we can do in each of the two coordinates, X and Y coordinate, we can factor out 2 from the numerator and the denominator. So we get 20 times square root of 2 plus 2 times square root of 13 divided by square root of 17 plus 5 times square root of 2. So here I've missed out plus 2 times square root of 13. That's also going to be there. This will be plus square root of 13. And the Y coordinate will be, so we're going to factor out 2 from the numerator and the denominator. So we have 2 times 8 times square root of 13 minus 6 times square root of 17 divided by square root of 17 plus 5 times square root of 2 plus square root of 13. So this is going to be the coordinate of the incenter of the triangle. And here we were provided with the coordinates of the midpoints of the sides of the particular triangle.